Hey there, so welcome to Module 5. Module 5 is a continuation of Module 4. I know a lot of the modules in this class are kind of standalone modules, but this one really goes, I mean, it almost could be combined with Module 4 in a way. We're going to talk more about sets, and we're going to cover sections 2.3 and 2.4. So we're going to start with 2.3, which has to do with using Venn diagrams to study set operations. So operations meaning like union, intersection, complement, the operations that we learned about in Module 4. So there's a method for shading the solution to a set operation, because in this section you're going to be asked to shade the region. On Connect you'll have some choices because you won't actually be able to shade, but you should shade on your paper, and then when you go to Connect you'll see that you'll be able to select the area that needs to be shaded. So I copied down in our notes, I copied down the steps from the book, which are right here. I like all of them, which is with the exception of this very first step, draw a diagram for the sets with Roman numerals in each region. I'm going to actually cross Roman numerals out and just put numbers. I'm just going to use numbers. I think it's simpler. We don't use Roman numerals on a regular basis in real life, so I think not just regular numbers makes more sense. So the first thing we're going to do, let's do this example, and then I'll refer back to these steps so we can make some sense of them. So in this example, we're asked to illustrate. That basically just means shade the set A union B complement. So I'm first going to draw a rectangle, and I'm going to draw 2 circles for A and B because I only see A and B. If there was a C in here, I would draw 3 circles. So I'm going to draw 1 circle on the left, 1 circle on the right, and I'm going to label them A and B. It doesn't matter which one is A, which one is B, so just pick. In the book and on Connect, the A will always be on the left, so it might make sense to just do that. Okay, so the next thing we're going to do is, so I've drawn the diagram for the sets. Now I'm going to label each region with a number. So I'm going to put a 1 here, 2 here, 3 here, and a 4 on the outside. So there's 4 regions in this diagram. So 1 is the region of A that's not touching B. 2 is what they have in common. 3 is just B, the part that does not touch A, and 4 is on the outside. So next what I'm going to do is I'm going to write down what's in, I'm going to list, so step 2, so instead of Roman numerals, I'm just going to put using the numbers, list the regions for each set. So I'm going to start with A. So set A has numbers 1 and 2 in it, because set A, and actually let me just use a different color here so we can really clearly see. So this is A. So set A has numbers 1 and 2 inside of it. Set B has numbers 2 and 3 inside of it. So if I use a different color for B, you can see that 2 and 3 are both inside that circle. So we've got A, we've got B. We can also, I'm going to write down the universal set, which is the set of all of the numbers inside the diagram. So we've got 1, 2, 3, and 4 are all the numbers inside the diagram. Now that we have that, we can go ahead and do A union B complement. So step 3 is we're going to actually work out the problem. So, and I'm going to write that here, work out problem. So we labeled the diagram, we wrote out the sets, now we're going to work out the problem. So to do A union B, I'm going to look at these sets. Remember, A union B just means to combine. Anytime you see that U symbol, which is union, it means to combine sets A and B. So put all of these together. So we've got a 1, a 2, a 2, and a 3. So we're going to put those all together. I'm only going to list the 2 once, though I don't need to list it twice. So I've got a 1, a 2, and a 3. Those are the numbers if I combine these together. Neither of them have 4, so that's why I'm not including the 4. Next, I'm going to do A union B complement. Remember, the complement means, think of the word not. So what is not in this set A union B? So if A union B is 1, 2, and 3, look at the universal set. What other numbers would be not included in the set 1, 2, and 3? Well, 4 is what's left out. So the answer to A union B complement would be the set with only 4 in it. And so we're going to shade region 4. And region 4 is the entire outside of the diagram. So I'm just going to shade all of this. Okay. All right, so the next example is very similar. So this would be a great place if you want to pause the video and try it on your own and see if you can do it on your own. So I'm going to start by drawing the diagram, and it's going to look very similar to what I have above. So I'm going to do a circle for A. I'm going to do a circle for B, and then I'm going to go ahead and label all the regions. So 1, 2, 3, 4. The awesome thing is when you do a diagram with two circles like this, it's always going to be the same picture. So you can just keep doing the same thing. So we can look above where we did up here and write down, just basically copy down what we had above. So we've got our universal set, we've got A, we've got B. Okay, my pen is super thick. I'm going to change it here. There we go. Okay, and then now I'm going to actually work out the problem. So let's go ahead and work out A complement, not union, it's an upside down U, so that would be intersect B complement. So this symbol means in common, which is different than combine, which is union, what we did above. Now to do this, what I'm going to do, I'm just going to scroll up to give me a little bit more space here. I'm going to first do A complement, I'm going to then do B complement, and then last I'm going to combine them together. So I'm just going to come over here on the left and I'm going to write down A complement. So remember complement, think what's not in A. So if A is 1 and 2, then the complement is going to be 3 and 4. It's the other numbers in the universal set that are not included in A. So 3 and 4. Okay, and then B complement would be what's not in B. So if B is 2 and 3, then B complement is 1 and 4. Okay, and so then what we're going to do, and it's nice I actually wrote these on top of each other, we're going to do the last step is we're going to find the intersection. So what do those two sets have in common? Well, they both have a 4 in common. So our answer is going to be 4. So we shade region 4, and if you notice, we actually get the same exact picture that we got the first time. And what we just proved is De Morgan's laws, which are down below here. De Morgan's laws state that, I'll just highlight this here, that A union B complement is the same thing as A complement intersects B complement, and that's what we just showed. They also, the law also states that A intersect B complement, we didn't show this part, but equals A complement union B complement. These are not rules that you have to remember. To be honest, we're not even going to really rely on these all too much at all, but it's an interesting way to create these first two examples since we need to know how to draw these diagrams anyway. So let's keep going. I'm going to scroll down and let's do an example where we have 3 sets. So I listed out in the book, it shows what all the regions, how you should label them, or how you should think about all the regions. Let me show you in a picture, and you can always refer back to that if you need to, but I'm just going to start by drawing the picture. So draw a Venn diagram to illustrate the set. I'm not going to say it all right now, but all of that basically. Okay, so I'm going to draw a bigger box this time because I need to fit 3 circles. And let's see, so in your book, usually most of the problems and you know what, actually I'm going to go back. I'm going to use different colors. Most of the problems have 2 circles on the top, so I'll call that A, and then, whoops, I meant to make that a different color, and then we've got B, and then I've got C. Okay, cool. So now what I'm going to do is I'm going to go ahead and I'm going to label all of these regions, and you're going to label these the exact same way every time you do one of these problems with 3 circles. So I'm just going to start with this region and call this 1, 2, 3, 4, 5, 6, 7, and then 8. So I have 8 regions now instead of 4. Now I'm going to list out all those sets. So my universal set is going to be numbers 1 through 8 because those are all the numbers in my diagram. A, so that would be any number in that red circle. So 1, 2, 4, and 5. 1, 2, 4, and 5. B is any number inside the green circle. So 2, 3, 5, 6. I'm choosing to write them in an ordered way. You don't have to. C would be everything in the blue circle, so 4, 5, 6, 7. Okay, and then notice 8 is by itself, so it's not included in A, B, and C, which it shouldn't be. So these are the sets. Anytime you have one of these problems where you have these 3 circles, you can just refer back to this diagram and then this list of sets. It's not going to change. What changes is the actual problem. So now the problem that we have to do is this. So I'm going to write down what we do first. So we kind of approach this like we use order of operations, similar. So we're going to start inside the parenthesis and find the intersection there. Then I'm going to do the complement. It's kind of like an exponent in terms of the order that we're doing this. And then I'm going to go ahead and intersect what I get from there with A. So let's first do, so step 1 would be B intersect C. So what do B and C have in common? So if I look at B and C up here, it looks like they have a 5 in common, and it looks like they have a 6 in common. So I'm going to write down 5, 6. So that's what they have in common. So, and you can even write in common. Okay, so that's step 1. Step 2 is I'm going to find the complement of that. So what is not, that's what that means, what is not in the set B intersect C? So if B intersect C is 5, 6, then the complement of that would be all the other numbers except 5, 6. So 1, 2, 3, 4, skip 5 and 6, 7, 8, okay? And then step 3 is going to be to intersect that set with A. So I'm just going to write that down over here so we can clearly see it. And then A is 1, 2, 4, and 5. And just so it's clear here, I'm going to label this B intersect C complement. Okay, so now I'm going to look at what they have in common. So it looks like they have a 2 in common, a 1 in common, a 4 in common. So my answer, so my final answer, A intersect B intersect C complement, is the set of 1, 2, and 4. So that is my answer. Now what I'm going to do, and actually it's my answer, but I actually have to go one step further and I have to shade the diagram. So I'm going to take, I'm going to shade regions 1, 2, and 4. So region 1 is just this part of A, 2 is this part, and then 4 would be this part. All right, so we're done with that one. So, and keep in mind, these take a lot of practice. So I think, you know, it's the kind of thing where, you know, you might not get it the first time, and that's totally okay. You got to do sometimes quite a few of these before you get the hang of it. So the next part is called cardinality of a union. So we talked about cardinality in Module 4. So cardinality just means the number of elements in a certain group. So for instance, I'm going to back up, or in a set. If I said up here, what is the cardinality of B? I would say it's 4 because there's 1, 2, 3, 4 numbers in B. Same with A. Cardinality of A is 1, 2, 3, 4. And so there's this rule here, and I'm going to highlight it. And it's not going to make much sense now, but we'll use it, and hopefully it'll make more sense after we use it. So this rule states that if you want to know the number of elements in the union of A and B, well, you add what they each have together, and then you subtract the overlap. Okay, and let's talk about why that is when we do an actual problem, because it'll make more sense. Okay, so let's look at this example. So we've got a survey of 100 randomly selected freshmen walking across campus. It turns out that 42 are taking a math class, and I'm just going to jot down some notes here. So total is 100 students, 100 freshmen. 42 are taking math. 51 are taking English, and 12 are taking both. How many students are taking either a math class or an English class? So this question here, this is why we do Venn diagrams. So if you've been wondering, why the heck are we even doing this? Like, what's the use? Well, when we have numbers for different types of groups, and we're looking to find answers to questions like this, it's much, much, much easier to draw a Venn diagram so that we can answer these types of questions. So what I'm going to do is I'm going to draw a Venn diagram, and I'm going to put two circles for math and English. So I'm going to go ahead and I'm going to call the circle on the left math, and then I'm going to call the circle on the right English. And then I'm going to go ahead and fill it in. Now, a lot of times what people do is they start with at the top and they say, okay, math is 42, and I see students do this. The problem is that's wrong. So take a minute and think about why that might be wrong. Why can't I take, if 42 students are taking math, why can I not just stick the 42 right there? The reason is the math circle is all of this red, and there are some students that have math and English that are in this middle section. And if I put all 42 on the outside, what this is saying is, hey, all of those 42 students are in only math and not English, and that's not true because I have 12 that are in both. So rather than start with the 42, because we don't know how many of those 42 are in this section and this section, I'm going to start at the middle. So I'm just going to put a note here that says start here. So that's going to be your middle section, your overlap. So if 12 are in both, I'm going to put 12 there. Then I know that now I'm going to back up. So if 42 students take a math class, well, that's all the red circle. Then there's already 12 in here. Then figure out, well, how many needs to go here so that altogether I have 42. So what you're going to do, I'm just going to draw a little arrow here, is you're going to do 42 minus the 12 to get 30. So now if you look at the math circle, there is 42. You don't see the number 42, but there's 30 and 12, and that together is 42. So then we're going to do the same thing with English. So English should be 51, but I can't just put a 51 here because there's already 12, and that wouldn't actually add to 51. So what I'm going to do off to the side here is just do 51 minus 12, and that gives me 39, and so I write 39 in this section. So all together in English, I've got 39 and 12, which adds to 51. And then I've got to figure out what needs to go on the outside. So to figure out what needs to go on the outside, what I'm going to do is figure out, well, what's already in the diagram. So I've got 30 plus 12 plus 29, or not 29, 39, and I'm going to figure out what goes there. Okay, and then I'm going to subtract that from 100, and then I'm going to figure out, so this is 81 when I add those up, and then I'm going to do, there should be 100 in the diagram altogether, and I'm going to take off 81. I've already got 81 in the diagram, so if I take off 81, then that's 19 left over. So there's a 19 on the outside. Now that I've completed the diagram, this is the hardest part. Now I can go and actually answer the question. So I'm going to come back up here, and it says how many students are taking either a math class or an English class. So what I'm going to do, if I want students that are taking a math class or an English class, that means any of these numbers that would apply. Students that are only taking math or taking both or English, and I'm going to add those together. So to get my answer, I'm going to come down here. So my answer is going to be 30 plus 12 plus 39, and when I add those all together, I end up getting 81. Okay, so that's my answer for that one. And if you think about it, notice that the 30 and the 39, those were not even a part of the original problem. So had I not done this diagram, it would have been very difficult to answer that question. Okay, so we're going to do the next one. This one's a little bit different because it's already filled in. But let's start with A. So find the cardinality, which means the number. So think N means number. So how many elements? Just means how many elements are in A union B. So what we can do is we can just count. We can see that we circle A, and here's circle B, and we want to know how many, the union is everything all together. So it's all of this would be the union. So if we count, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, if you want to, so I'll just go over how you might see it done in the book or Connect. So you can use that cardinality rule that I mentioned on the previous page. And this is how it works. So let me erase this. You take, if you want the number of elements in A combined with B, you take all of A. So technically all of A is everything in this red circle. So how many elements are in there? We've got 1, 2, 3, 4, 5, 6. So there's 6 elements there. And then I take all the elements in B. So I've got 1, 2, 3. Uh-oh, notice this one I already counted before. 5, 6. So 1, 2, 3. Oh no, 1, 2, 3, 4, 5. So we're going to add 5 there. And hopefully you can see already that it wouldn't be accurate to add 6 and 5 and say that there's 11, because see how I double counted those ones in the middle? So now you can see why this rule has us subtract the ones in the middle. So if there are 2 in the middle, I'm going to take off 2, which allows my answer to not include any double counting. So 6 and 5 is 11 minus 2 is 9. That's the exact same thing I got above. It's more complicated than you need to do, or it's a more complicated route than you need to use, because you can just count, but I just wanted to show you how that rule works. And then for the second one, so what is the number of elements in B minus A? So I'm going to show you 2 ways to do that. So the first way, I'm going to do it how I did it in Module 4. So I'm going to list out B. So what elements are in B? And B is right here. So I've got 4, 5, 6, 12, and 16. 6, 12, and 16. And then I've got A would be on the left. So we've got 4, 8, 9. And you don't have to put these in order. I just prefer to do it. It's personal preference. B minus A says take all the elements in B that are not in A. So what I like to do is I like to cross off any that are similar, since we don't want any elements that are in A, and you cross them off. And then once you cross them off, you take the leftover elements, so all the elements that are in B and not in A. So the answer here to B minus A is the set of 5, 6, and 12. Okay, I'm not asked for those elements though. I want to find the number, the cardinality of that set. So that means the number of elements. So I've got 1, 2, 3 elements. So the answer is going to be 3. The number of elements in B minus A is 3. So that's my answer. So we got 3 for that one. Okay, so we've already been solving some problems, but section 2.4, it's titled Using Sets to Solve Problems. We're going to continue drawing Venn diagrams and then using them to answer questions. So let's look at this first one. And this would actually be totally a good spot for you to pause the video and try this on your own. So in 2008, there were 36 states that had some form of casino gambling in the state. So I'm just going to write a little note, casino, 36 states. 42 states sold lottery tickets of some kind. So lottery, 42. And then 34 states had both casinos and lotteries. So I'm going to write both is going to be 34. And then we're drawing a Venn diagram to represent the results, and then they want us to find how many states have only casino gambling, how many have only lotteries, and how many states have neither. So notice with my numbers here, so 36 states have a casino. That doesn't tell me 36 states only have a casino. Some of those might have a lottery. So we've got to draw a Venn diagram so that we can isolate those numbers and answer these questions. So I'm going to draw a Venn diagram with 2 circles. I'm going to draw one on the left, and I'm going to call this casino, and then I'm going to draw a circle on the right, and I'm going to call this lottery. And then I'm going to go ahead and start filling it in, and I'm going to start with the both number. So start here. So I'm going to put 34 right in the middle, and then I'm going to work my way back. So casino, 36 states. So if 36 states have a casino and I already have 34 in there, then 2 has to go here because 2 and 34 make 36. So to write it down, it's 36 minus what's in the center, 34, and I end up getting 2. So that's how I get the 2. And then the lottery, I've got 42 lottery states, but 34 is already in the middle. So I'm going to subtract 34 and I end up getting 8, and that's going to go in that space. And then to figure out what's on the outside, we want to know how many total states are there. We weren't given that information in the problem, but in this case you can assume there are 50 states in the US because that's common knowledge. So I'm going to say 50 states total. And I'm going to subtract the casino only, and then the both number, and then the lottery only. And I'm going to take off all of those numbers to figure out what's left. There's 6 left, so that goes right there. And that's your neither. So these 6 states have neither a casino or a lottery. So that's one of our answers. So one of our answers is 6, that has neither. And then let's go ahead and answer the other question. So how many states have only casino gambling? So only casino gambling is going to be this 2 number. So 2 states. And only lottery is going to be this 8 number, 8 states. So once I have the diagram, answering the questions isn't too bad because I've done all the hard work by creating the diagram. So those are my answers to those 3 questions. Okay, so this next one, I have a heading here, using the cardinality of a union rule. So now I will tell you, some of these problems, you'll start doing these problems and you'll think, okay, piece of cake, I'm going to just approach this like all the other ones. And some of them are a little bit different, and you actually have to end up using the cardinality of a union rule. And most of the time, I know in my case, when I'm doing the problems, I kind of run into a roadblock where I realize, oh, I have to use some other rule because I don't have enough information to do it any other way. So let's just jump into this one and I'll explain for what I mean. So out of 25 students taking an exam, so I'm just going to write a note, total students 25. 14 answered the first of 2 bonus questions. So first question, there were 14 students. 19 answered the second, and 1 didn't bother with either. And actually, you know what, I'm going to put neither there instead of, I should either have to say don't bother with either, didn't bother with either, or neither. Okay, now there's a huge difference here with the last few. So notice the last couple problems, we were given that both number. So in this case, it was 34, and then if we look above, what was on the previous page, we were given that 12 students, whoops, my scrolling's getting out of hand. There we go. We were given 12 students were taking both a math and an English class. That makes the problem easier when you're given that both number. So with the problem that we're working on, it's a little bit harder because we're not given that. So let me just start by drawing the picture. Okay, bear with me. My computer is being slow. There we go. Okay, so I'm going to draw a box. And I'm going to draw a circle, and I'm going to call this first question. And then I'm going to draw a second circle and call this second. And normally what I would do is I would start by filling in the middle, which is given by usually in the problem. But since we're not given that information, you're going to have to use the cardinality of a union rule. So of a union rule. So let me write that out. So the number of elements in A union B is equal to the number in A plus the number in B minus the number in both A intersect B. So let's write down what we what we know here. And you know what? Oh, I forgot this part. The one that neither number, I can put that in the diagram. So if I have one student that didn't answer either of them, then I can put that one on the outside. So I can definitely do that. Let's think about what A union B would be. So A union B is both of these circles. If I know there are 25 total students and there was one that didn't answer either, then 24 must be in these circles altogether. So I'll just write that over here on the bottom left. So the number of A union B is going to be 25, which is the total, minus 1, which is the number of students that didn't answer either, and that equals 24. So there are 24 students that answered either first or second or both. So 24 is going to go there. And then the number in A, so we know in A in this case would be our first question. So there were 14 that answered the first question, 19 that answered the second, and I don't know what this is. You could call it X or a question mark or write out N of A intersect B, however you want to write it. So I'm going to go ahead and simplify this. So 14 plus 9 is 33, and instead of the question mark, I'm just going to say minus X. I'm trying to figure out 33 minus what number is 24, while 33 minus 9 is 24. So I'm going to say X has got to be 9. So then I'm going to go ahead and I'm going to put that 9 in the center. Okay, so just to back up, what did I do? The first thing I did was I filled out all of this stuff. So I read the problem and I filled out all those numbers. The second thing that I did is I figured out the number of A union B. The third thing that I did was I used the cardinality of a union rule. And then the fourth thing is I put that number in the middle and I put it in the diagram. And so now I'm going to go ahead and I'm going to try to figure out what numbers need to go in the first and second circles. So if there are 14 people that answered the first question correctly and there is already 9 in the intersection, then what I'm going to do is I'm going to do 14 minus 9, okay, and that equals 5. And then for the second circle, if there were 19 people, I'm going to do 19 minus 9 since there are already 9 inside of that circle, and I end up getting 10. So we know that the question asks, what percentage of students tried both questions? Well, both, ask yourself what part of the diagram is both. So the part of the diagram that represents both questions would be over here, which would be 9. So to answer the question, what I'm going to do is I'm going to find the percentage of 9 compared to the total. So the percent of both that percent of students that tried both is going to be 9 students out of 25 students to get total. So if you're ever asked for a percentage, you want to know the total. That's going to be your denominator. And we get 0.36, which is the same thing as 36%. So our answer here is going to be 36%. So I think that's probably one of the trickier problems in this section, that problem and then the next one we're going to do. And I think honestly, if you can do this problem and then the next one, you're going to be in really good shape. And then just keep in mind, you can always refer to this video as you're doing these problems on Connect because they're going to be really similar. Okay, so this next example. These problems, so this is a 3-circle example. It's harder if you're not given a table. If it's a paragraph, just make sure you're really good listing everything out on the side as you read the problem. So it starts by saying a survey of 300 first-year students at a large Midwestern university. So I'm just going to say the total students, that's 300. It was conducted to aid in scheduling for the following year. Responses indicated that 194 were taking math. So math is 194. 210 were taking English. 210. 170. Whoops, I'm going to be consistent here. 170 were taking a speech course. So those are your 3 circles: math, English, and speech. In addition, 142 were taking both math and English. So math, help if I could spell math. Okay, math and English. There we go. Let's see, 142. Okay, and then 111 we're taking English and speech. And then 91 were math and speech. And 45 we're taking all three. So all three is going to be 45. So I'm going to draw a Venn diagram. So you want to make your box nice and big, and you're going to draw 3 circles. So I'm going to draw a circle in red, and I'm going to call this math. And then I'm going to draw a circle over here and call it English. And then I'm going to draw another circle and I'm going to call it speech. It does not matter which one you decide to make each, which category. I will say that if you're having trouble on your homework and you click on show example and connect, I would do your diagram like they do theirs, so that way you can easily compare. The next thing that you're going to do, let me just scroll this up a little bit, is you're going to start at the very bottom, kind of like we did with the diagram with 2 circles. So you're going to start here. That's the only number that we can actually put directly in the diagram. And let me explain why. This math number, 194, that's referring to the entire math circle. So this region and this region and this region and this region all together are 194. I do not know, based on that number, I don't know how many need to go in each region. So I can't put the 194 anywhere right now. So, but what I do know is that 45 did all 3, or scheduled for all 3. So I'm going to put 45 in the part where all 3 circles overlap, which is right in the very center. So I put 45 there. Okay, next. So I'm going to work my way up. So I start at the bottom and I work my way up. So math and speech, try to use your pencil and try to identify where do math and speech overlap. So it looks like math and speech overlap right here. I've already got a 45 in that circle. So what I'm going to do is I'm going to take, to get the number that goes here, I'm going to take 91 and I'm going to subtract 45, since 45 is already in that region, and that gives me 46. Needs to go here. Now when you're doing it, you don't have to necessarily draw all these arrows. I'm doing it just so that it makes sense to you guys where I'm getting all my numbers. Next, English and speech. So I'm working up the numbers here, and I'm just going to put check marks when I'm done. So English and speech would be where the blue and the green overlap. So it would be like right here, that sliver. Okay, I've already got a 45 in it, so I need to take English and speech, which is 111, and subtract 45 since it's already there, and then I get 66. So now in English and speech, I've got 66 and 45, which together make 111. So that checks out. And then math and English, I'm going to identify where those overlap. That would be right in this section here. So I've already got a 45 there. So I'm going to take the 142 and subtract the 45, and that gives me 97. So 97 is going to go there. So those I think are the hardest for most people. And now speech, that's the entire speech circle. So that's all of the green. So let's think about what's already there. So the total speech needs to be 100 and, is that a 2 or, and that looks like a 7. Let me just double check. Yep, 170. Okay, cool. Can't read my own writing sometimes. So there's 170 total speech students, but I've already got these 3 numbers that are inside of that speech circle. So I'm going to take off the 46, take off the 45, take off the 66, all from the 170, and I'm left with 13 left over. So you're going to put a 13 here. So at the end, if you want to check your work, what you could do would be to add 13, 46, 45, and 66, and that should all equal 170. Okay, so we've got that one down, 2 more to go. So English, 210. So I'm going to just write down 210, that's my total English, and I'm going to subtract what's already in the English circle. So 97, 45, and 66. So minus 97, minus 45, and minus 66. And when I do all of that, I end up getting 2. So there are 2 students who only registered for English and none of the other classes. And then for math, so last but not least, we're going to do 194 minus the numbers that are in the red circle already. So 46, 45, and 97. Oh, and bear with me. Oh, there we go. Cool. My computer has been freezing up lately. 45 and 97. Yeah, and then I get 6. So 6 should be there. So that is the hard part, is getting all of this filled in. And then once you get to the questions, sometimes they can be tricky, but for the most part, the hard part's over. So part A asks how many students only were taking an English class. That's going to be 2. The 2 is the part of the diagram where those people are only in the English circle and they're not overlapping with any of the other circles. So I'm going to say 2 there. And then math and speech, but not English. So where do math and speech overlap? That would be like where the red and green, but not English. So we're only going to go with that 46. C, math or English. So when you have an or, you're going to count all of the numbers. Or means count all math, English numbers that you can see. So I'm going to count, let me just erase this just so I have a little bit more room here. All of the math and English. So that means 6 plus 97 plus 45 plus 46 plus 66 plus 2. So 1, 2, 3, 4, 5, 6. We should have 6 numbers. 1, 2, 3, 4, 5, 6. Awesome. And when we add those all together, we should get 262 students. And then last, none of these 3 subjects, that's going to be the outside. Oh, and you know what? I didn't actually fill that in. So I'm glad that they asked. So to fill in the outside, let's just take our total, which is going to be 300, and you could use I would use a calculator for this part, and subtract every single number that you see on the inside of the circles, and then you'll get what needs to go on the outside. So if there's 300 people total, I'm going to take off the 6 and the 97 and the 45 and the 46 and the 66 and the 2 and the, whoops, I'm missing the 13. And before I do this all, I'm going to count and make sure I've got them all. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, that looks good. I take away those all from 300, so use calculator if you need to, and I get 25. So that's going to be the number of students that didn't register for math, English, or speech. So none of the 3. So that's going to be the answer to question D. So that concludes the notes for this section. Like I said, a lot of these problems require a lot of practice. So keep in mind, it might not happen right away. And then as always, make sure you send me an email if you have any questions. I'm happy to help.